spherical, now down to rectangular. So let's say we have a point that is in spherical coordinates. Let's just grab a radius of 3, let's say, and an angle. Now, these are the nice ones because we can actually pick very nice angles. So let's say pi over 3, and let's do some pi over 2 for this one, for phi. So let's convert that one. So at this point, these are the easier ones because you just plug it in. So I'm going to do just one of them. So x is going to be 3 times the sine of pi over 2. And then times the cosine of pi over 3. Now, sine of pi over 2 is 1. Cosine of pi over 3 is 1/2. What a nice example I gave myself. So 3/2. I like it. Now, y is going to be 3 times the sine. Oh, because sine of pi over 2. Oh, that's so silly. This is not a good example. Well, it's a good example, but because if phi is pi over 2, you're automatically in the xy plane, because you're starting here to measure the angle. You go down to pi over 2. So today, I guess I got 0. So, well, it was a good example, I thought. Now, this is going to be sine of pi over 3. And the sine of pi over 3, sine of pi over 2 is 1. Sine of pi over 3 is square root of 3 over 2. So we get 3 square root of 3 over 2. And then for z, you just get to do 3 cosine of pi over 2, but that's going to be 0. I guess that's the theme now. So 0, but in this shape. And that is because, again, we are in the y plane. So this point corresponds to just 3/2, 3 square root of 3 over 2, comma 0. All right, so that was that. So not very difficult. So now let's erase here and let's find out what the formulas would be to convert from cylindrical to spherical, and vice versa. All right, so let me erase here and I'll be right back. All right, so let's think about how we go from one to the other. So remember, and I probably shouldn't have erased all of the ones I had here, because for cylindrical coordinates, I need to have r, theta, and z. So z I already knew how to do from the one before. And then I'm going to be converting back and forth from rho, theta, phi. So some things don't change, right? You notice that theta is theta. Okay, that's a very tautological statement. You have an identity there. You have to do nothing about it. But then z, you also had already a way to relate it, because you had that z was nothing but rho cosine of phi. So this, if you have the point rho theta phi, you already have theta and z right away. So how do you compute r? Well, r, remember we said, was rho sine of phi. I drew the picture a little bit earlier, so those equations should be straightforward. So now if we want to go backwards, so what do we do? So now I want to have r, theta, and z, and I need to figure out rho. So I have to now solve in some sort of way, or obtain rho out of r. So how do you do that? So let's draw the point again. Like so. And let's see, then we had our radius. The ones I need to draw is rho. And then I need to project down to r. And I had the angles. Theta, which is going to be the same one. And I had phi. So now if I have r, theta, z, and I need to find rho, how do I do that? Well, I have a triangle here that has r and z and rho related. So the way you do it is by doing a Pythagorean theorem. So you get rho squared is going to be equal to z squared plus r squared, which is going to just give you that rho is the square root of r squared plus z squared. So if now I have my point in polar coordinates, I can find rho by plugging it into here. And now theta, again, we said theta equals theta. Very tautological. And then what do I need? I need a phi. Solve from here, and you're gonna have that phi is gonna be given by z over rho. Well, I guess I wrote the cosine of phi. Z over rho, and then you have, which is not the same as z times rho, which that would be 0. Then you get that phi, not theta. Phi is going to be equal to the arc cosine of z over rho. So you use this formula now to convert from one to the other. So here, if you're given your cylindrical coordinates, you can convert them into spherical. And if you're given spherical, you can convert them to cylindrical. And then converting is really just using the formulas at this point. There's really nothing fancy about them in this case. So we're not going to go through an example. I think that the formula suffice. All right, well, thank you for watching, and I'll see you in the next one.